welcome to IIT Bombay and for this talk from Vitalik. So I assume many of you don't need this introduction, but I will still do a brief introduction about Vitalik. He is younger than many of us and he is the founder of Ethereum platform, which is central to many of the smart contracts. I would say that is the only one platform that allows programming on the blockchain. So let's hear from the expert about this platform, its potential, its problems, etc. So without wasting any time, I will give it to Arifa, who will introduce Vitalik a bit more.
Hello ladies and gentlemen, for those of you who have been with us over the weekend doing the Ethereum hackathon for the first time in India, you would have already realized the vast potential of this decentralized platform. And just to give you a brief profile of Mr. Buterin, he's been in India in December. He was born in Kolomna, Russia. And every few decades we have the privilege to witness such dramatic revolutionary technologies like the decentralized technology that we've seen in Ethereum. And even more remarkable is the rise of Ethereum since its invention. First of all, to take a leap from Bitcoin, from Satoshi Nakamoto's vision and imagination, and to conceptualize something that would be all-pervasive, that would be a general-purpose computer but on a decentralized platform, was nothing less than marvelous. And not only that, but to have built a community which is overwhelmingly organic, and to have built a passionate ecosystem of developers who have been developing applications on this platform, that it has its own momentum now and it is self-sustaining. So you can say that the successors of Ethereum or any company, you have the continuity risk if a high-profile person or an inventor recedes from the scene, but in this case the developers have proven to be of such metal that they have come up with really unimagined applications and on an unforeseen scale. And not only that, not only having built the organic community, one of the other things that sets apart Ethereum is that Vitalik, unlike a lot of founders, made this a non-profit foundation and dedicated himself just to increase the adoption of Ethereum and to make it mainstream, and to make it as commonplace and as easy for everybody to operate on it as possible. So we can look at it as the TCP/IP protocol in terms of its intellectual caliber. We can also look at it as Windows next version, but on a decentralized scale. So with such accomplishments behind him, it is really remarkable that Vitalik is a very down-to-earth and modest person, as you can see in front of you. He was born in Kolomna, Russia. And he was brought up in Canada, so he's been living in Canada since he was of age 6. And he learned the preliminary computing from his dad. In fact, both his parents are engineering graduates, and they were both mathematicians. And his favorite plaything as a child was the Excel spreadsheet. So his dad presented to him one of the old computers when he was barely 6-year-old, and since then he's been playing with numbers and algorithms and stuff. And since he introduced the Ethereum concept, I think in 2014, in one of the Bitcoin conferences in USA, he has not stopped to mesmerize people with his vision and his invention. And the first block of Ethereum was only mined in late 2015, which was probably July. And within a couple of years, Ethereum is really soaring. And if you see the cryptocurrencies, they are on a manic rise. Currently, the Bitcoin is touching $1,900 and Ethereum is touching close to $100. And it was less than $10 just a few months ago. The meteoric rise started just this year from January. And a lot of factors have compounded to make Ethereum what it is, and one of them is also the fastest growing and the most compelling enterprise Ethereum Alliance network, with a lot of biggies like Microsoft joining the alliance and leading it. So currently Ethereum's market cap is close to a $10 billion, and I remember Vitalik talking at IIT Madras saying Ethereum's valuation is anywhere between 1 and 3 billion. So within a few months, it is now $10 billion, and the cryptocurrencies market itself is like $15 billion. So that also gives you not just the intellectual value of it, but also the commercial value placed by the market forces, which couldn't be fairer. So with that, I hand over to Vitalik to enlighten us on the cryptocurrencies and his vision for Ethereum and the protocol and what challenges he's been facing in development of distributed ledger technology and as a chief scientist of the Ethereum Foundation. Thank you, Vitalik, for being with us.
All right, thank you, everyone. So unfortunately, because of a combination of that, myself not having HDMI and my internet totally not working, I might not have slides right now, but that's okay because I can just talk. So I guess I will, I do not have that one. So I'll probably start this off by going back to the start and going back to the kind of the days in 2011, 2013 when Bitcoin and was still fairly young. Ethereum did not even exist, and people were still just starting to think about just like the kinds of ideas that we're thinking about in this space. At the time there weren't really that many projects. I mean, there weren't that many people building applications, but there were quite a few people thinking about the ideas, understanding the ideas, realizing I can help you here. Settings, display, mirror. There we go. Mirror displays.
As you can see, Vitalik's laptop is customized to him. No one else can operate it.
It's called Ubuntu. But mirror aside. And keep this configuration. There we go. Cool. Yeah, so, back in 2011 and 2013, people were just starting to kind of get into Bitcoins, and at the time, pretty much nothing else existed. And people were just starting to think about, the core ideas, things like decentralization, trustlessness. What are these things for? What do they mean? What are their benefits in cryptocurrency? Do they have benefits going beyond cryptocurrency? So the story of Bitcoin itself starts in 2009 when Satoshi Nakamoto published the Bitcoin white paper and then published the first version of the Bitcoin source code. But people were thinking about decentralized networks, peer-to-peer cash, all these other kinds of like trustless, trust minimizing, trustworthy applications for quite a long time before that, right? So if you remember back to the 1990s and even the 1970s when public key cryptography was invented for the first time. And public key cryptography for its time was a very powerful idea, right? The idea here is that if I have a message, then I could digitally sign it. Basically, I could run a mathematical process on my computer and I would generate this big number. And I could send you the message and this big number that we call the digital signature. You would be able to run another process on your computer, and you would be able to verify that this message actually came from me, right? You would be able to just look at the message, look at the number, and know, yes, this number actually does mean that this message came from myself. So the interesting thing about this is that public key cryptography, even by itself, is enough to power a very large number of decentralized applications. Let's say we want to have a decentralized protocol just for sending messages to each other. I want to say, hello to my friend, but I do not want other people to be able to read what I just said. I would want to preserve my privacy. Also, I might want to send messages to people, and I want those people to be able to know that those messages actually came from me. Theoretically, people can do this between each other. You don't need to involve any kind of central server. You don't need to involve any kind of central trusted third party. And just with public key cryptography, with this kind of mathematics that lets you create and kind of verify these numbers, what you can do is you can actually get a fairly good amount of security, right? First of all, you can ensure privacy. So you can ensure that any messages that you send, only you and the recipient can see, no one else can see them. You can ensure authenticity. You can ensure that people know that the messages actually came from you. You can ensure that the messages are what you sent, that they have not been modified in transit. And so you can kind of use math to get a whole bunch of guarantees about this interaction that you're having with someone else. And this by itself is a pretty powerful idea. And so a lot of people were thinking, well, okay, we can have secure peer-to-peer messaging. And with the internet in the 1990s, the idea of making decentralized networks started to grow pretty soon after. You can have decentralized networks for sending messages to each other. You can have decentralized networks for sending files to each other. Now, what if, the next step is that we could have decentralized networks for sending money to each other. And this is where things started to get a bit more complex, right? So the reason things started to get more complex is this. At first, it might intuitively seem like money, it is just information, and you could just take like paper bills and digitize them, and you would have digital bills, and you would be able to just send them around like files. But there is a problem. If I have $100 in my wallet, and I give those $100 to my friend, I do not have these $100 anymore. Now, let's say I have 100 digital dollars in my wallet, and these 100 digital dollars are just a file on my computer. Then, okay, I can send $100 to my friend, but then guess what? Maybe I could copy the file. I could have a backup of the file. And so I sent those $100 to my friend. My friend has the $100, but I still have the same $100, and I could send the same $100 to another friend. This might seem like a great thing. Yay, free money for everyone. No more taxes. We can fund lots and lots of wonderful things. Everyone can be rich. But in reality, if money actually worked this way, it would hyperinflate faster than Zimbabwe. So the problem is that money is something that is kind of like information, but it operates differently from other kinds of information. Right? So the main difference is this. If I'm having a conversation with my friend, then that conversation is just between me and my friend. No other person theoretically needs to know even a single thing about it. But if I am sending money to a friend, money is inherently social in a way that one-to-one communication is not. With money, the fact that I am sending money to my friend is relevant not just to me and to my friend, but it's also relevant to everyone else in the community that uses that currency. Because everyone else needs to know that I do not have the money anymore to give back. And so this is the main difference, right? So this is the thing that was kind of tripping people up for a long time. And eventually, in 2009, Satoshi Nakamoto came up with this thing called Bitcoin. And why is Bitcoin interesting, right? So the interesting thing is that finally, after 30 years of various attempts of trying at this problem, we finally have a solution for how do we make a peer-to-peer decentralized digital currency. And so, there's a lot of people have different opinions about what the solution is. Some people say that the main kind of secret ingredient is proof of work. Some people say that the main secret ingredient is the idea of decentralized network. Now, I would say a decentralized network is a tool, and proof of work is a tool, but they're really only one particular way to implement a much more powerful and general tool. And the much more powerful and general tool that I'm talking about is cryptoeconomics. Now, what do I mean by this? Well, basically, cryptoeconomics is the use of cryptography and economic incentives in order to maintain information security objectives. So if you're just sending messages to your friends, then all you need to achieve your information security objectives is cryptography, right? If you have cryptography, then if you want, you can encrypt stuff, protect your privacy, you can sign stuff, other people know stuff came from you. Now, for digital currency, you want a few extra guarantees on top. Yes, you want people to know that if a transaction was sent, that who the transaction was actually sent from. Yes, you do not want it to be possible to impersonate other people and take their money, but you also want a few other things. So here's one example of what makes this problem harder. So let's say I have the $100, and these are 100 digital dollars, and I issue 2 transactions. One of those transactions sends those $100 to one friend. Another transaction sends the same $100 to another friend. Now, clearly, in isolation, either one of those 2 transactions is okay. In isolation, the transaction sending the $100 to my first friend is totally fine and it should be accepted. Or the transaction sending $100 to my second friend is totally okay and should be accepted. But if I send both at the same time, then the network should only agree on one of them and throw out the other. And everyone has to agree on which one gets accepted and which one gets thrown out. So this is one of the kind of extra guarantees that you want to have. Now the other interesting thing about a currency is you want to have guarantees not just about what happened in the past, but you want guarantees to hold into the future. So for example, let's say the network has some process for agreeing that one transaction is passed, got accepted, and another transaction did not. One property that you want is that you do not want the network to change its mind, right? You do not want the network to accept one transaction and then say, no, maybe I'm going to accept this one instead. No, maybe I'm going to accept this one instead, right? You don't want your money to be able to go back in time. So here, we can start talking about using, hold on. Thank you, that's the slide. We can talk about using cryptography in order to kind of secure and maintain guarantees about messages that happened in the past, and economics as an incentive mechanism to encourage properties to continue to hold into the future. So, in the case of next. So, what kinds of properties do we want to have, right? So, in the case of Bitcoin, you have this data structure called a blockchain. So, people send, anytime he wants to do something, whether you're sending money in Bitcoin, whether you are sending a transaction in Ethereum to register a domain name, to participate in a contract, to open a payment channel, anything that someone wants to do in a blockchain is a transaction. And these transactions are cryptographically signed, so you know who sent them. But then you want the network to agree on what the order of these transactions is. And so these transactions get grouped into blocks, right? You have these nodes in the network that package up these transactions into blocks. And each block points to some previous block. And so you have this kind of chain of blocks that's supposed to keep on growing and growing. Hence why it's called a blockchain. Now, what are the properties that we want to hold about this thing to hold? One of them is we want the chain to keep growing, right? We want new blocks to get generated, and we want blocks to get generated at the end of the chain. The other one is we don't want the chain to revert stuff, right? If the chain goes like this, we don't want people to just be creating new blocks that going over here and then just and forgetting about the old chain. We want there to be one chain, and we want the one chain to keep on growing. So Bitcoin has a fairly simple economic incentive to encourage all this to happen. And the incentive is this. Blocks get created by a special class of user that we call miners, and anyone can become a miner basically by buying a special kind of computer and plugging it in and basically burning a bunch of electricity. And miners have this kind of incentive. If a miner manages to generate a block, and if this block is part of the main chain, so if this block becomes accepted as part of the history, then you get a reward of 12.5 Bitcoins. If you do not mine, you get nothing. If you create a block, but the block is not part of the history, then you do not get a reward, and you actually kind of get penalized in some sense because you burned a bunch of electricity, wasted money for it, and you got nothing for it. And so what you have is, basically this mechanism where if you as a participant in the network contribute to the network kind of acting in a way that's nice, you get money. And if you contribute to the network acting in a way that's less nice, you lose money. And so this is kind of a very simple application of how crypto economics can work in kind of building these kinds of systems and encouraging them to have certain properties. Now this is philosophically very interesting, right? Because it's this weird kind of recursive game where you have a system And that system, as part of its own rules, defines a set of economic incentives, and those economic incentives are the incentives that create this kind of network, this ecosystem of users that maintains the network's ongoing existence, right? So the system itself creates and maintains and implements the incentives required for its own self-perpetuation. And this is a philosophically pretty interesting and powerful idea, right? And you can kind of see how it's difficult to fully wrap your head around, at least at first. So this happened. Then, at first people were very excited, 2011, 2012, around just using this as a digital currency. You have this blockchain, and you can use this blockchain to keep track of the order of the transactions, and to kind of get everyone to agree on this database of who has how many coins at some point in time. And people started thinking, well, what if you could use this for other applications? So in 2010, there was a project that was invented called Namecoin. And the idea behind Namecoin was to use exactly the same kind of technology for a distributed domain name system. So basically, instead of being registering domains through these kind of networks that are hooked into centralized servers, you would just have the whole thing run on a blockchain. The processes would all be transparent. So, you would not be able to interfere with the system or shut it down. It would be completely open and fair. And there were at least a few people that were interested in this. Now, Namecoin, the specific project, did not end up going very far, although the idea of running domain name registries and kind of name registries in general on the blockchain is one that I think is proving more and more powerful as time goes on. And there's at least 5 different registries on different blockchains that are kind of existing and being substantially used right now. So that was the second application. Then 2012 started going even further. There was a project called Colored Coins. And the idea behind Colored Coins is, well, okay, you have one digital asset called Bitcoin, and this is a kind of native digital asset. It's an asset whose only existence is defined inside of the protocol itself. And so the only reason why it has value is because of the properties that the protocol gives it. But what if you could use the protocol also to represent the ownership of other kinds of assets? So what if some company, some bank could, let's say, keep 100 kilograms of gold in some vault and issue 100 kilograms of digital gold. And each gram of digital gold would be a token that lives on the blockchain. And this token, and the company will then guarantee that this token is redeemable by 1 ounce of actual gold, or by 1 gram of actual gold. And so if you have digital gold, then if you really wanted to, you could kind of reclaim the gold that it's backed by. Now, the idea here would be that, this would allow people to kind of much more easily save in gold, and they would not need to kind of deal with the physical security of having actual gold in there that they'd have to store. They could just deal with it, securing a cryptographic key, and it would be kind of instantly tradable, instantly viable, sellable, and accessible. So this is the next thing that people got interested in. Now you might ask, well, one of the problems of using blockchains in order to store this kind of digital asset is, well, that kind of system seems kind of centralized already, right? It seems like, okay, all of the actual gold that's backing the digital gold is in a vault. Well, what if the vault gets robbed? What if the company runs away? What if the government that the gold is based in decides to seize it? And so, that's definitely a problem. But I would say blockchains definitely do add value. Because here, if you use a blockchain to maintain the database of who has how much gold, here are some things that the operator of the system can't do anymore. First of all, the operator does not have the ability to just randomly drop one particular user's balance to 0 without anyone's noticing. The user theoretically does not have the ability to do any kind of manipulation of people's balances without everyone noticing, and without basically forcing people to switch over to an entirely new system. Right? So the user, the operator, it's much harder for them to cheat. It's much more, It's much harder for them to, let's say, issue more units of gold than they have actual gold backing it, and it's much harder for them to do lots of various kinds of malicious things, right? So even if you're not building an application that's completely decentralized, adding some amount of partial decentralization can often still increase security and still make your application one that's easier to trust because it's harder for people to cheat. So that was the next step. After this, people started thinking, okay, let's go beyond colored coins. Let's start thinking about other more complex applications of blockchains. Can we use blockchains to run crowdfunding campaigns? Can we use blockchains for financial contracts? Can we use them for title registries? Can we use them for gambling, prediction markets, a whole bunch of other different things? And the number of use cases started multiplying. So, at one point there was this project that I was working on, and in this project there were at least like 20 different types of transactions that were supported by this one particular blockchain protocol. And what they basically did is they said, okay, we'll have a bunch of guys come together in a room, and we'll brainstorm for an hour, what are the different things that people might want to do on a blockchain. Here's a list of 20 applications. For each application, let us make one type of transaction. If you send a transaction and the first byte is a 0, then it represents moving money around. If the first byte is a 1, it represents entering a financial contract. If the first byte is a 2, it represents closing a financial contract, and so on and so forth. And so now you have blockchain protocols that are a bit more general than just supporting one application. You go up from supporting one application to supporting 20 applications. You go from a pocket calculator to a Swiss Army knife. But then, eventually you start to realize even this is not general enough, right? The problem is, okay, you create a blockchain protocol, and this protocol supports 20 different types of application. Great. Well, 1 week later, some teenager in Finland comes up with a 21st type of application. And now, you have to redesign the entire protocol again. And so, seeing this actually happen basically is where the idea for Ethereum came from. So I was working on one of these protocols, and I started realizing, oh wait, the use cases are multiplying. And so I thought, well, instead of adding new transaction types, instead of adding, yet another 7 different types of transactions to handle 7 different applications, how about taking some of the existing transaction types and making them more general? How about going from, just binary options contracts to options contracts that are defined by a mathematical formula? How about going from 2-party agreements to n-party agreements? How about going from just money to generalizing across other types of assets? And so after a couple of weeks of thinking about this, I started to realize that the best way to do this kind of protocol is really not even to think at the bottom level from the point of view of what the applications are going to be. Instead, at the very bottom level, you want the protocol to be as abstract, as general purpose as possible. You want a protocol where the only thing that's defined at the bottom level basically is a programming language. And then whatever you would want to build on top, whatever application you would want to build, you would write the rules of that application as a piece of code, upload the code to the blockchain, and if you wanted to interact with the application, you would send a transaction, and the transaction would say, this is the chunk of code I want to interact with. Then, when the blockchain processes that transaction, it would run that piece of code and execute the rules of the application as they were written. So, this was the basic idea, right? You could, instead of having a blockchain designed for one application, or even a blockchain designed for 20 applications, you can have a blockchain that's designed to be able, that can theoretically support any application as long as that application's logic can be written in a piece of program code. So that's where kind of the vision started, right? And that's where things started to get more interesting. So at the start, when I first came up with the idea for Ethereum, I was only thinking about a fairly small set of applications in mind, most of them having to do with finance because most people in what was then still called the Bitcoin space were thinking about finance. But then over time, I started realizing that people were coming into this community, and the kinds of things that they were building, which I had never even thought of myself. Right? People were designing, things like decentralized file storage systems, decentralized computing systems, DAOs, decentralized identity management systems, reputation systems, all these different things that I had not even imagined this platform would be used for. And that's the power of making things that are general purpose, right? You make things that are capable of supporting things that you would not, at the time that you were creating the protocol, would not even be able to imagine, right? So, just like when you build a computer, when companies build computers, the computer contains a built-in operating system, and this operating system can run a really huge bunch of programs. Anyone can run a program for it, and a computer that was built 10 years ago can, in many cases, execute programs that are written today. And these programs will do things that the developers of the computer 10 years ago would not even have imagined. So that's the kind of spirit that I thought that it would make sense to bring into the blockchain world. So fast forward a bit more. 1.5 years, mid-all of 2015, Ethereum launched. Keep going from there. Since then, we've passed through a number of technical improvements. Homestead 6 months after launch, then there was a release called Spurious Dragon in October. Right now, we're moving toward Metropolis, which is the third one after launch. And there's also an increasing number of people building lots of different interesting things on top of Ethereum, right? And you see a whole bunch of applications, pretty much all the way along the spectrum, ranging from various financial applications, decentralized exchanges, financial derivatives exchanges, digital assets, price-stable cryptocurrencies, to completely non-financial applications, anti-counterfeiting, identity management, to things that are all the way in between. And also ranging from things that are very simple, like either just currencies or like rock, paper, scissors on the blockchain, going all the way up to very complicated DAOs. You would see projects that are fully decentralized. You would see projects that are hybrid. You would see projects that have different elements of centralization in them. You would see projects that are public. You would see projects that are permissioned. And you see projects that are being developed entirely by just individual developers, some by startups, some by banks, some by startups in collaboration with banks, some by governments, some by startups in collaboration with governments. And so, the Ethereum space and the blockchain application space in general is actually getting extremely diverse at this point. And to be fair, that's something that should be happening with any industry that's going the right way, right? I mean, if you look at, the computer programming space, like that's something that's so diverse today, we don't even think of it as being a space, right? Or, I imagine to a lot of people, computer programming is just as natural an activity as like picking up a spoon. How many people here pick up their keyboard more often than the spoon? Yeah, see? So, basically, look, there's a lot of ways that whether or not something is going mainstream. And, if it's being used in a whole bunch of ways and people are just starting to talk about it, like, not just like it's this fancy, crazy new idea, but also like it's just like a boring thing that people are supposed to have already heard of, then you're getting somewhere. So, I would say we clearly are getting somewhere, right? So, what is the point of all this, right? So, what interesting things have we accomplished? What interesting things are we trying to accomplish? What interesting things could we accomplish? What is the point of making things? Yes, back. So, what is the point of making things that are decentralized, right? And I would say there are several answers here. And these answers tend to range from the technical to the political to the social to the economic. You actually find some of everything, right? So One of the simplest ones is, it's this kind of idea that you can build applications that are zero infrastructure. If you build a blockchain application, you do not have to run a server. You do not have to do anything. Basically, you would just have to upload the application, and theoretically, users would be able to run it just between themselves. So this is powerful for a couple of reasons, right? One of them is that it means that you as a developer do not have to worry so much about, is my centralized thing going to get attacked? Is my centralized thing going to shut down? Is my centralized thing going to have a bug in it that'll require me to just manually turn on the server again? Is my centralized thing going to get attacked? Is my centralized thing that the application depends on going to get infected by ransomware and with the hacker demanding $300 of Bitcoin? If you build a decentralized application, a lot of these problems do become alleviated because there is no centralized thing that can get attacked, that can fail, that can break. Practically speaking, a lot of these blockchains, even the blockchains that are very tiny, that only have a few hundred users, practically speaking, they have higher uptime and higher reliability than Gmail. So, that is what decentralization gives you. So that's the first thing. High security. Also it's just very difficult to attack the entire application. High reliability. Global. So one of the main reasons why a lot of people like cryptocurrency is that it's totally independent of national borders. It's just as easy to send 1 unit of Bitcoin or 1 unit of Ether from Kyrgyzstan to Guatemala as it is to send that 1 unit to your own neighbor. And these networks are open and anyone can participate. So the other really interesting one is this idea of a social cost of bootstrapping. And there's two sides of the coin here. One of them is what I call social scalability, and the other is what I call social cost of bootstrapping. So here's the problem with the social cost of bootstrapping. If you, in general, as an entrepreneur, build some new application, one of your challenges is you have to convince people to use it. One of the challenges of convincing people to use it is you have to convince people to trust it. How are people going to trust it, right? So how many people here, if they saw some random guy on the street creating Papa Joe's financial derivatives market, would be willing to throw their money into this Papa Joe's financial derivatives market? Very few. Now let's suppose that Papa Joe's financial derivatives market was a smart contract, was a program that ran on top of a blockchain, and that came attached with mathematical proofs showing that either the whole thing functioned according to certain rules or you get your money back. How many people now would be more willing to put some money into Papa Joe's financial derivatives market? There we go, right? So, that's what I mean by social cost of bootstrapping. Basically, the idea is that we can replace social costs of gaining trust. So things like gaining reputations, things like convincing centralized authorities that you are respectable, things like wearing expensive suits, things like making big fancy buildings, with technological costs of trust. And the nice thing about technological costs of trust is that social costs of trust tends to go up year after year after year. In the 19th century, one of the main reasons that banks would build these big, impressive buildings is that they wanted to convince people that they are a sturdy, reliable institution. They are not just going to go bankrupt the next year. And these days it's more subtle, but you can see a lot of that behavior pretty much everywhere. And the thing with technological cost of trust, though, is that technology becomes twice as efficient every 2 years, year after year after year. So, what kind of cost of trust would you rather be paying? So that's part of the promise of blockchains, right? That you can substitute expensive social ways of gaining trust with cheaper and cheaper mathematical, technological, cryptographic, and economic ways of ensuring trust. That's one side of the coin. Here's the other side of the coin, social scalability. So let's say you wanted to build an application where that application is just meant for people that are inside of that one village. Chances are they can find people inside of that one village that are trusted by almost everybody. Like there might be some, friendly village elders that are just respected and loved by just about everyone. people might like the mayor, people might like the sheriff. I mean, there might be just like respected wise men. There might be some company that everyone trusts. Now expand from a village going to a country. People might still trust the government. People might still trust a few large companies, but it becomes harder. Now let's imagine building an application that's designed for people across the entire world to cooperate. So then the problem is, are there really even any single sources of trust that are trusted by absolutely everyone? If we're going to build an application for the entire world, who's going to run it? How many people here would trust Google to run it? How many people? Some. How many people here would trust the government of Kyrgyzstan to run it? How many people here think the government of Kyrgyzstan would trust Google to run it? Now, here's a different question. How many people here trust that people in Kyrgyzstan like money? How many people here trust that cryptographic hash algorithms work in North Korea? See, so if we build applications where the story of why you need to trust, of why you should trust that application, doesn't depend on trusting specific individual institutions, organizations, or authorities, but instead it depends on crypto economics, then we can build things where it's much easier to convince people on a large scale to go along with them. Because if you're building decentralized applications, then that's the only way you have of really credibly convincing that you're not trying to become the new king. No, you're trying to get rid of the king. You're trying to make systems that can actually work without a king, right? You can actually convince people that you're actually building a thing that's designed to let everyone collaborate with each other and not designed for you to find some way to mooch off of it at the center. Now, going back to social cost of bootstrapping, let's even assume that everyone is a nice guy. Well, here is another social cost of bootstrapping that's hard to ignore. If somebody creates, let's say, Papa Joe's notary, and then, okay, let's assume that Papa Joe is honest. Here's the problem. What if Papa Joe's notary service shuts down? So what if someone builds an application which is dependent on Papa Joe's notary, then Papa Joe's notary shuts down, then someone tries to verify something that Papa Joe's notary did, and now this service is shut down, and so no one can access it anymore, no one can interact with it anymore. That's a problem, right? If a service shuts down, and then people who depended on the service are going to encounter some inconveniences. So instead, what if you build a decentralized notary? Then, okay, maybe there might still be some need for Papa Joe to be some kind of service provider as part of this decentralized application. But then, first of all, if one particular service provider ends up shutting down, another one can take his place. The second thing is, if one service provider shuts down and nobody takes his place, the records on the blockchain are still there. You can still use the records on the blockchain to figure out what happened. You can still use the records on the blockchain to migrate to some new application that somebody else builds later. You can still use the records on the blockchain to convince a court of who did what in what order. And so, that's actually a big benefit, and it helps people a lot. So that's another example of one way that reducing the social cost of bootstrapping is a good thing. So these are all just some examples of benefits, and I would say the kinds of blockchain applications that generally make the most sense are applications that, at least in some sense, are about coordination. Right? So they are applications that ultimately are about solving problems that say, here are a few hundred different people, groups of people, protocols, in institutions, companies, governments, whatever, around the world. Right now, those groups are not interoperating, and they might not be interoperating either because of various kinds of trust problems, or because of various standards of compatibility, or for various other reasons. And can we build a decentralized thing that can get people who are not interacting to interact over an open protocol? And so this is actually one category of blockchain application that seems to be working fairly well across many industries, whether it's finance, whether it's identity, whether it's a whole bunch of different categories. Another example of an area where blockchain applications can work well is providing very cheap infrastructure to people where traditional institutions are not willing to provide infrastructure because it's not worth it for them. One simple example, banking. There's a whole bunch of people where traditional institutions don't want to give them bank accounts. Not because they're evil, not because they're malevolent, but just because, well, there's no money in it for them. And so with blockchains, what you can do is you can create these extremely cheap, extremely kind of low-cost, reliable, global forms of infrastructure that can be used by pretty much anyone with a computer and the internet. And for the computers and the internet are actually becoming a lower and lower bar with every passing year. Right? Computers are getting twice as cheap every 2 years, and the internet is only becoming more and more pervasive. So if there's one kind of common infrastructure you're willing to rely on, it might as well be that. Or going beyond money, we can even talk about things like insurance. Right? Insurance doesn't have to be something that's provided by a company as a product. It could be something where people organize into pools and provide insurance to each other. We can even talk about things like identities. Like the concept of an identity does not necessarily have to be issued by a government. It could be just a combination of claims by a bunch of people who already have other identities that say, I know this person and he is my friend and I trust him. So, there's actually a lot of these interesting applications where if you start thinking about them in this more decentralized context, then there's a lot of interesting possibilities. So that's where we are from a kind of applications point of view. Now, from a technological point of view, we've come quite a long way, right? We've come from just having a blockchain that can just do money to having a blockchain that can run basically general purpose computer programs. But we still have a long way to go. So 3 main challenges that I often talk about. Number 1, security. Number 2, privacy. Number 3, scalability. What do I mean by security? Now, the underlying protocols of these systems tends to actually be pretty secure. Right? The underlying protocols tend to actually work fairly well, and they tend to be very difficult to attack. The security challenges tends to be more at the edges. If I write a computer program that represents the business logic of some application, what if there's a bug in the code? And what if this computer program controls $50 million of people's money? What if you're creating an application, and in this application people have accounts, and what if somebody loses their password? What if someone loses their private key? What if someone loses their phone? So both of these are kind of more user interface challenges than anything else. And they're actually kind of interesting and unique challenges because if you look at the first example, right, the first example is, if you have a program, how do you know there aren't any bugs in it? Well, this is something that in a lot of contexts, people like NASA, people like aircraft software manufacturers have been working on for a while. Because there are a lot of areas where you're writing software, and if the software has bugs in it, very bad things happen. But here you have an even more interesting scenario because these smart contracts are software where if it breaks, bad things could happen. But it's not just accidental errors that you're worried about. It's also malicious errors. Right? You want to create systems where just like regular individuals who are thinking of participating, entering into some contract, participating in some application, have the ability to know whether or not this application actually is trustworthy, whether or not this is something that they should participate in, whether or not what they intuitively think the terms are is actually reflected by what the terms are that are written in code. And this is a challenge. From an access control point of view, so how do you make sure that people can keep their accounts, even if they lose their passwords, even if they lose their devices? Basically, the main challenge is that you want to do this without reintroducing some central point of control that can just give everyone their accounts back. Because once you do that, then you've just brought back a single central point of failure and a single central point of thing that can get attacked. So this is a challenge. Privacy. So one of the properties of blockchains, for better and for worse, is that all the data on a blockchain is public. Right? Everyone can see everything that is on a blockchain. Problem is, for a lot of applications, people want privacy. Right? People do not want the entire details of their financial history, what applications they participate in, what they do, to be visible to everyone. There are a bunch of solutions, and they range from kind of low-tech solutions to high-tech solutions. So low-tech solutions, for example, would be, instead of using one account for all your applications, you would try to break up your usage into as many different accounts as possible. One account per application, possibly 10 accounts per application if you get away with it. Higher tech, we can talk about fancy forms of cryptography, things like zero-knowledge proofs. And one of the nice things about these fancy forms of cryptography is that they let you get the benefits of using the blockchain to verify that rules are being followed. But because of the way that the cryptographic magic is being done, you can verify that the rules are being followed without knowing anything about the specific thing that is being done at any point in time. And so you can have transactions where the content of those transactions is completely privacy preserving, but where at the same time you know that each and every single transaction follows the rules. So that's another interesting extreme. And between those two kind of categories of solutions and everything in the middle, there's a whole bunch of different possibilities that we can try and kind of think about, start using. And if we can kind of combine a bunch of these together, then we can probably get to the point where we kind of have enough privacy that a lot of people will be comfortable using this technology. Third major challenge, scalability. Bitcoin can do 4 transactions a second. PayPal can do over 2,000. The Shanghai Stock Exchange can do 80,000. I imagine the Indian Stock Exchanges also do quite a few. So IoT, probably, it's expected to hit 25 billion devices by like 2020 or 2025. I even forget these days. That's going to be even more than 80,000 transactions a second. So, there's a gap that has to be filled there, right? We need to basically come up with better blockchains that can actually handle the kind of load that real-world mainstream usage is going to impose. And this is a challenge. And, all of these problems are things that we all, both in terms of we as kind of core protocol developers of the underlying blockchains, and as application developers of people that build things on top of these blockchains, and people in the community all need to think about, and should kind of should be kind of working together to try to solve. And hopefully in the next few years we'll keep on solving them and keep on pushing technology to the point where it can kind of support the next level of really interesting things. Thank you.
Any questions?
So when you said that there is a core developing team who develops a protocol, is there an incentive mechanism for them to be pro-system? Because if there is somebody who wants to do something that can be malicious.
Yeah, I mean, it's making sure that incentives between the core developers of a protocol are aligned with the users is definitely a challenge. So, like the main, I guess, practically speaking, there's basically, just speaking very generally, there's 2 things that we can rely on. One of them is reputation, and the other one is that the core devs tend to be people that got into a cryptocurrency very early on, and so they hold a lot of units of that cryptocurrency, and so their personal fortunes depend on it doing well. So, this is true across a whole bunch of different systems. Now, in my opinion, both of these incentives are kind of very imperfect because, for example, there's a lot of ways to preserve your reputation, but move away from working on a cryptocurrency to working on something else. And there's a lot of ways for Ether as a cryptocurrency to do really well, but at the cost of Ethereum be useful as a platform. So I think it's definitely nowhere close to being a perfect incentive, but it probably is kind of basically the closest anyone's come up with at this point. There are protocols that try to kind of have in protocol mechanisms where the protocol itself figures out whom to pay for development, which I think is an interesting idea. It is, in my opinion, a bit too fragile to try and put into kind of bottom level systems like Ethereum. But for applications on top, so for things like DAOs, I think doing something like that is great.
So isn't it in that sense a centralized still?
It's, well, I think development communities can be centralized and can also be decentralized. So for example, in the case of Ethereum, there's at least 4 different implementations of the Ethereum protocol that are being used by people. And these implementations are being built in a lot of cases by independent organizations. So like the Go client is built by the foundation. The Rust client, which a lot of people are using, is built by an independent company called Vitalik. And encouraging multiple implementations is a deliberate kind of social design choice that we made in order to encourage more development decentralization. Yeah.
With so many organizations adopting Ethereum and also developing their own platform on top of it in their own way, kind of tweaking the code to make their own implementation, don't you think so in the near future it will again lead to the same Swiss knife problem again that we had with the Bitcoin?
To the same what problem?
The Swiss knife problem that you mentioned.
Yes,
with Bitcoin.
I see. I would say that it's possible, though on the other hand, I would say that first of all, kind of baseline Ethereum by itself, because it is capable of general purpose computing, there is a less need to modify it differently for every single application. So the reasons why people tend to modify Ethereum right now tends to be because the mainline Ethereum chain is a public chain and they want a permission chain for some applications. And this is actually something that can be standardized, right? So you can make a permissioned Ethereum package, and this would be usable across a whole bunch of different applications. And it could even be designed in order to be maximally kind of code compatible with the public chain, so that applications that exist on the permission chain can also be ported over and just like run on the public chain. And so you have this kind of synergy of developer network effects. And like this is the kind of roadmap that like the Ethereum Enterprise Alliance is trying to go towards. So like I think if we kind of work hard to standardize things, then I think we can definitely like reduce the amount of kind of duplicated work that ends up getting done. And I think also if we continue to try to lean on the generality of the Ethereum protocol itself instead of trying to kind of tack on every single thing you might want to do as a new feature.
Vitalik, thank you so much for giving the world a very disruptive application. My question is around computation. With the scalability issue, right? I mean, there's going to be a limit to the computation, the resources that is going to be attached to this blockchain and ultimately Ethereum. So, in terms of valuation, there's going to be a cap in the Bitcoin valuation and ultimately the other cryptocurrencies like Ethereum. So, do you see that the threshold coming, and what could be the possible solution?
Yeah, so I have in several contexts online brought up the idea of what I call a kind of cryptocurrency congestion anti-network effect, where I basically say that blockchains, at least blockchains as they are today, are kind of like cities. Where if a blockchain is too small, it's like a small town and it's boring, nobody lives there, you don't really want to go there, and all the interesting and fun people just leave and go to the big cities. But then if a city gets too big, then you have a whole bunch of traffic and it becomes really expensive to live there. And so in practice, you don't see one city ruling them all, you see this kind of distribution going from small to big depending on what people like and what their preferences are. This is true now. Now, in my opinion, one of my main projects is that I'm working on blockchain sharding, which is the idea that you can have blockchains where the total capacity of a blockchain is much larger than the processing capacity of any single computer. And you do this basically by implementing a protocol where every single node only processes a small portion of all the transactions on a blockchain. And my view is that if we can design sharded blockchains and make sharded blockchains secure, then these congestion network effects can be mitigated to a large extent, basically because these systems will be able to scale to much higher volumes. Now, I do think that there are going to be trade-offs on the margin at kind of very high levels. So for example, there is an inherent trade-off between the decentralization of a system and the ability of a system to, for example, finalize a transaction in 3 seconds. Right? So like finalizing a transaction in 3 seconds is something a permission chain can do, but a public chain can definitely not do without incurring very serious risks of just being economically centralized into one actor. And so this is one example of a kind of trade-off where I could see, for example, some chains being kind of bigger and more open and more decentralized at the cost of being a bit slower, along with this kind of array of like smaller side chains. Some of them open, some of them permission, where they would have higher performance at the cost of more centralization, and you'd be able to kind of fairly easily just go between them depending on what your preferences are for each application. So I could see something like that happening.
So a lot of businesses today rely on there being lack of transparency and a central authority. But in a lot of cases, that's a good thing in the way that, for example, if my bank charges a commission on any transaction I make, that's the reason why the bank exists in the first place.
Right.
So as a business, that may just be my incentive to have the business, open the business in the first place. Right? So my point is, it's great to have something which is decentralized and where everybody is pooling in together to get something done. But I mean, is it? I don't know. What's the incentive for anybody to do this in the first place?
So I think first of all, a world that runs on decentralized protocols is definitely not a world where it's not possible to make profit, right? I think even in a world with a lot of decentralized protocols running everything, there still are going to be plenty of opportunities to do things on top. Where just like we have the internet, and the internet is a fairly open protocol, and people can sell computers, people can sell like internet access, people can act as nodes in the system, people can sell a whole bunch of different services. And I think any kind of decentralized economy, things like this will continue to exist as well. So the harder problem though is, how do we incentivize the creation and maintenance of the decentralized protocols in the first place? And I think in general there's a few different models for this. So one of the I'll probably list the major categories like this. One of the models is what I would call the patron model. So the idea is you would find some large institutional actor where this large institutional actor gains a substantial benefit from the decentralized protocol existing, because this protocol does not compete with them. Instead, this protocol competes with centralized actors that this particular institutional player is already fed up with. And because of that, this institutional actor would be willing to fund it and maintain it. Practical examples of this in the real world might be, let's say, Google funding Android and Chrome because they, as a large institutional actor, benefit from the existence of a strong and open internet. That's option one. Option two is you would find some kind of incentive that's inside of the protocol itself, and you would find some way to kind of monetize the protocol-based layer. Now, what that means today is basically a crowd sale, but I imagine in the future that we'll come up with like more interesting models that try to kind of take the benefits of that kind of paradigm, but also add kind of more long-term sustainability to it. I mean, the third approach is that the whole thing is just kind of run as a volunteer effort, which is definitely insufficient for a lot of things, but there are probably going to be some things that it is sufficient for. So far, it's basically like some combination of those three approaches that's been tried so far, but maybe someone very clever will come up with something else too. Yes?
Yeah, so the way the blockchain in Bitcoin has miners who are incentivized, what does Ethereum have?
Right now we have miners just like Bitcoin does. In the medium term, we are planning to switch to something called proof of stake. And the idea with proof of stake basically is that anyone who has Ether will essentially be able to become kind of like a virtual miner. And so like depending on how much Ether you have, you'll get assigned some kind of ability to participate in the consensus process. And the reason why we're doing this is basically because it saves energy, because you don't need to like pay for so much actual computing hardware anymore.
So the reason why
moving from POW to POS?
So the major one is basically that proof of stake is more efficient, so it doesn't need to consume as many resources. And I also have the belief that proof of stake is more secure long term, basically because, like with proof of work, if someone does a 51% attack, there's not really that much that you can do about it, right? They do a 51% attack once, then okay, you can find some way to recover. But then you still have the hardware, and so they can do the 51% attack again. You recover again, you do the 51% attack again. And so they can just keep on attacking your chain over and over again and basically prevent it from ever coming back to life. In proof of stake, here's what you can do. Suppose that there is a 51% attack against a proof of stake system. Now, suppose that this happens, then in order to recover from this 51% attack, there is, let's say basically the community agrees on a hard fork that will just continue the chain going with some new set of stakeholders. You can just, as part of this fork, you can automatically delete the money of everyone that participated in the attack, because with the way that these protocols work, you have a total cryptographic proof of who the attackers are. Then okay, basically they managed to knock the blockchain offline for 3 days, you deleted $200 million of their money. They attack again, you delete $200 million of their money again, they take the blockchain offline for another 3 days. So with proof of stake, it basically becomes extremely asymmetric because attacks are extremely expensive, but the amount of damage that those attacks can actually do is fairly limited.
Excuse me.
Yes.
So, talking about proof of work and proof of stake, so last year there was a problem with the, right, and that was due to the programming error. So, but the classical Bitcoin blockchain did not face any such problem. So, by introducing this programming language or this smart contract thing, are we a bit vulnerable? The exposure is a bit more?
I would say, so first of all, the flaw in the DAO was just a flaw in the DAO, right? It did not affect other Ethereum applications. So that's important because with Ethereum, if you do complex things on Ethereum, yes, you are incurring more risk, but if you're doing simpler things on Ethereum, then you're not incurring that much of the risk. And so like, it's not so much about imposing the risk on everyone as it is giving people more options. And yes, platforms that give people more options are going to give people the ability to do dangerous things, and they are going to give people the ability to walk off a metaphorical cliff. And you know, that's just part of what it means to empower people. And so, and I think in general, like practically speaking, it is important that we don't, that while there aren't the tools to do complex things safely, that you know, we don't encourage people to do those complex things with and in a way that puts too much resources at stake in case they fail. And over time, as we get better and better at doing the complex things, then you know, eventually the infrastructure will improve to the point where we will be capable of safely doing all of them. And I think we are already starting to get there. Like we already are starting to have things like formal verification, you know, and you know, in 2 or 3 years that's going to become even easier. I mean, we're starting to have much more solid programming languages, and I think it's only going to improve from here.
So that will be an extension to Solidity, or
yeah, I mean, it's extension to Solidity seems likely.
So, thank you, Vitalik. And one more thing, any thoughts on electronic voting and blockchain?
I mean, electronic voting, I think, is, I mean, first of all, it's potentially very powerful if you can do it right. But at the same time, there are definitely large security challenges in doing it right. I personally don't necessarily think that blockchains are the best tool to do electronic voting, basically because, like, well, it depends on what kind of electronic voting, but if we're talking about voting for things like national elections, then some of the key properties that you want are things like, you know, the votes need to be anonymous, and you have this property that's called coercion resistance, which basically means you should not be able to prove who you voted for even if you want to prove it. Basically, the reasoning is that if you can prove who you voted to, then you can just bribe people to vote for some particular person. And The problem is that blockchains as a technology are really heavily designed around the idea that everything you do can be cryptographically proven if you want to, because they are, that kind of is what it means to use computation to reduce the cost of trust. But unfortunately, that's not really a good fit for the specific needs of an electronic voting system. But I do think there are other very powerful cryptographic technologies that can help.
Thank you. One question. So you mentioned how proof of stake can resist 51% attack. But I feel that once 51% attack happens on the Ethereum, the second one might be cheaper because then the price of Ether will really go down.
I actually think that with a 51% attack, the price of Ether would go up. And the reason is this. So here are the consequences of a 51% attack on proof of stake. Consequence number 1, the blockchain goes down for 3 days. Consequence number 2, 5 to 10% of all extant Ether gets burned forever. That second thing might actually have a bigger impact than the first, right? And then there's also the fact that the amount of Ether needed to do the second attack, the attacker would have to buy all that up on exchanges, and so you can see how it could end up being self-defeating pretty quickly.
Thank you all for coming.
And thanks for coming. So we stop.